Hello, all. In continuation with our statistical problems in community medicine, we are going to deal with standard error of difference between two means and two proportions. In the previous video, we have seen about coefficient of variation and also the standard error and confidence interval. As I mentioned in the earlier video, standard error is the amount of error which happened due to the sampling which we make in our study results away from truth of the study population. And the confidence interval is a broad range where we say that 19 out of 20 times, that is 95 percentage of the times, we will be getting the values between these interval. So that standard error calculation was the comparison between your sample and the study population. But here in standard error of difference between two means, we are comparing the means between two groups and proportion between two groups. And we will say whether the actual difference in means or proportions have occurred due to chance or due to the significant difference. So that is what we are going to deal in this standard error of difference between two means and two proportions. First, we see the difference between two means. As we all know, the standard error of means is given by the formula sigma divided by root of n, that is standard deviation divided by root of n. Here the formula has been converted into the difference formula for two groups. It has been converted into standard deviation of the group 1 divided by the n1, that is number of samples of the group 1, plus the standard deviation of square of the group 2 and n2, that is number of observations, number of samples in the second group, and we have to take a square root also. So then we will get the standard error of two means. Here it means it is for the numerical variable, for example hemoglobin, like that. Then the formula for the standard error of difference between two proportions, the percentage, is given by this formula. As we all know, the standard error of difference between two proportion is given by the formula root of PQ by N. This is the standard error of proportion between the sample and the study population. Here between two proportions means then we have to modify the formula accordingly. That is, we have to take the square root of P1 Q1 divided by N1, that is prevalence of the first group, and Q1 is 100 minus or 1 minus P1. Same way Q2 is 100 minus P2. So prevalence in that group and Q2 divided by N2, N where N is the sample. So likewise we get the value of standard error of difference between two proportions. Then we need to calculate the actual difference. If the actual difference is more than two times of the standard error of difference, then we say that the actual difference is not due to chance. That is, when we are having a standard error of difference between two proportion as the value and the actual difference is more than two times standard error of difference, then we say this difference is not due to chance. If suppose we get the value less than 2 standard error, then we can say, that is, if the actual difference is less than 2 standard error, then we can say that the difference which happened between the two groups has occurred due to the chance. So now we work out one problem on standard error of difference between two means. So let us suppose we are testing the effect of a drug on mice. 24 mice, comparable in all respects, were randomly divided into two groups. Group A, the control group, that is no treatment was given. The other group was the experimental group. At the end of the experiment, the mice were sacrificed and the kidney of each animal was weighed in milligrams. The effects of the treatment on kidney weights was as follows. So among the control group, the 12 number, the mean weight was 318. Standard deviation was this. Among the experimental group, it was 370 with the standard deviation of 241. As we all know, the formula for standard error of difference is root of standard deviation 1 divided by n1 plus standard deviation 2 divided by n2. Sorry, this is square both standard deviations will be square. So here it is 10.2 whole square divided by 12 plus 24.1 whole square divided by 12. We need to take a square root also. So when we calculate it, we get 7.5 as the standard error of difference between two means. So when we get this, the 2 times of this standard error of difference is 15. Then we need to calculate the actual difference of mean. So the actual difference means mean 1 minus mean 2. So that is 370 minus 318. So we have got 52 as the actual difference, which means the double the value of the standard error of difference is 15. So since the actual difference is more than the double that of the standard error of difference, then we say this difference has not occurred due to chance. This difference is significant. We use the term significant. So here is the key for this. So the standard error of difference is 7.5. The actual difference is 52, which is more than twice of the standard error. That is into 2 if we make it is 15. So 52 is greater than 15. So the difference between two means it is more than twice of the standard error of difference between two means. So therefore it is significant and it has not occurred due to chance. So we can conclude that treatment has significantly affected the weight of the kidney among the mice. So that is how we work out standard error of difference between two means. Now we move on to the standard error of difference between two proportions. So the question is, let us suppose we are making a trial of two whooping cough vaccines. The field trial results were as follows. So vaccine A and vaccine B were the two vaccines. So number of vaccinated were here, number of exposures, number of cases were here. So calculate the attack rate. From above, it appears that vaccine B is superior to vaccine A. Find is there any significance. So we need to find the attack rate. So for attack rate, out of the exposures, how many are getting the disease will be the exposure. So for attack rate for group A will be 22 divided by 90 into 100. If we make, we will get 24.4 percentage of attack rate among a group A. Same way for attack rate for group B will be 14 divided by 86 into 100, that will yield 16.2 percentage. So it looks like the group A attack rate is 24.4 and group B attack rate is 16.2. It looks like B has a better protection rate since the attack rate is less here. So we need to calculate the standard error of difference between two proportion in order to say whether this difference is significant or not. Here we calculate first the actual difference. Actual difference is 24.4 minus 16.2. So that will yield 8.2. Now the standard error of difference between two proportion is given by the formula root of P1 Q1 divided by N1 plus P2 Q2 divided by N2. So here Q is 100 minus P. So we need to substitute that in formula 24.4 into 75.6 divided by 90 plus 16.2 into 83.8 divided by 86. So 90 is the sample size for this N1 and 86 is the sample size for this group B. Now if we calculate this, we get 6.02. So this is the standard error of difference between two proportions. So we have got this. So 2 times standard error will be 12.04. So this is greater than the actual difference. If suppose the value is greater than this standard error of difference between two proportion, then we would have said it is a significant difference and it has not occurred due to chance. But now the value is greater than the actual difference. So that is the actual difference is less when compared to the standard error of difference between two proportion. Then you can say this difference has occurred due to chance and not due to the significant effect of difference between two groups. So that is what written here. So the standard error of difference is 6.02, which we have found out from the formula, and the actual difference is 8.2. In other words, the observed difference between the two groups, that is 8.2, is less than 12.04. So twice that of the standard error of difference, that is 2 into 6 equal to 12. So we infer that there was no strong evidence of any difference between the efficacy of the two vaccines. Therefore, the observed difference, the actual difference which we got here, might be due to chance. So that is what we are proposing here. So there is no convincing evidence, statistical significant evidence to prove superiority of one drug over the other. So for that, we need to get the values more than double that of the standard errors between two proportion. So to sum up, in this video, we have seen about the standard error of difference between two proportions and two means. We have just modified the formula of standard error of means and proportion between two groups. So when we compare this, we get a value, the standard error of difference between mean or proportion we will get if the actual difference in mean or proportion is more than twice of the standard error of difference between two proportion or means, then we can say that the actual difference is not due to chance, or it is due to a significant difference between two groups. We can conclude that way. So that is the usefulness of standard error of difference between two proportions and mean. Hopefully you have understood about this topic. And if you like this video, please click on the like button and share it to your friends. If you haven't subscribed to the channel, please subscribe. Thanks for watching this video.